8.5 by 11 inches. That's how much your paper measures right now, the one that you guys currently have. Now, part 2 is asking you guys, how do you calculate the area of the paper before we cut it out? So, as is right now, earlier on we talked about this, right? Now, if you look at your paper flat right now, is this a 2D shape or a 3D shape? 2D shape. How do you find the area of a 2D shaped square? Length times? Wait, so remember in 2D we do length times width. Go ahead and show me what we do in your whiteboards if I ask you to find the area of this paper that you have. So again, 10 seconds. Show me your whiteboard. What will you do if I ask you to find the area of the actual paper? Show me your actual process. So show me your process. I'm not asking you for the final answer. I need to see just the process now. What is the process? Alright, go ahead and show me what you have. I don't want the answer yet, I just want to see the process. So everyone go ahead and show me. Show me whatever you have in your whiteboard. Show me whatever you have in your whiteboard. Whatever you have. That's fine. Good. So I need to make sure I multiply, right? Do you guys know how to identify which one is the length? Which one's the length, everyone? In this case, is it 8.5 or is it 11?
Oh, 8.5.
11. The length is 11. The length usually refers to the longer side, right? In this case, the length is 11. And obviously, you guys can see that in your paper, correct? And so therefore, which one's the width? 8.5. So in this case, I'm going to go ahead and just multiply 11 by 8.5. Alright, go ahead and use the calculator icons and go ahead and tell me what the actual value is now. So go ahead and use the calculator icons and go ahead and tell me what that value is. What is the actual area of your paper? Okay. The area of paper, I want it. So I want the actual value now. And then make sure that once you find it, you also include that on your decimals response to make sure that you guys get credit. Save here, make sure you use the other calculator as well. Alright, so Maya, what's the answer? 93.5? Does everyone agree? Good. So I know that the area of the paper in 2D is actually 93.5. Good. So again, in order to guys find the area of the paper in 2D, you just take length times width. So we take length times width. I hope you guys remember that. Okay, here a little typing, so I'm going to go ahead and wait. Finish whatever you're typing. Moving on. Alright. So now we're going to go ahead and mess with the actual simulation. I Write it in your whiteboard really quick. You have 5 seconds. What is the actual variable that they are using to represent the silent? In your whiteboard. In your whiteboard. What is the variable that they are using to represent your silent? What is the variable they are using to represent your silent? Then 5, 4, 3, 2, and 1. Go ahead and show me. Whatever it is you got. The variable is x. Okay? So the variable is x. So I want you guys to go ahead and grab the paper I gave you guys earlier. And I made you guys label it in 1 inch, correct? Label that 1 inch x as well. Because that right there, that little cutout that you guys have in every corner is called the silence, right? So make sure you also label those little boxes x's. Right here for yours. So everything needs a little square right here. Alright. Now I'm gonna go ahead and show you guys how to mess with the silent. Got Pablo? I need you guys to go ahead and try the number 1, 2, 3, and 4. Okay? You'll see what I mean right now. Again, your paper only shows for 1 inch. I want you guys to try it for 2 inches, 3 inches, and 4 inches. In order to do that, you need to go ahead and make sure you click on the silent. And I'm gonna go ahead and click on the number 1. Click 1 and click submit. 1 and click submit. Is this what your paper looks like? Yes. Your paper looks like this currently, right? Because all we have is for 1 inch. So what we have is for 1 inch, so therefore that's what your paper looks like. This image right here. And if it were actually to cut it out, what does it create? What does it create, everyone? A 3D shape, right? So again, we're going from 2D to 3D. It creates a 3D shape. So again, that's for silent 1. If you want to go ahead and try 2, 3, and 4, just make sure you replace the 1 with a 2 or a 3 or a 4 and click submit. Once you guys start seeing how it's changing, I want you guys to go ahead and tell me. I want you to predict. So I want you again to predict how the volume of the box might change as the side length of these square cutouts increases. And obviously you'll start seeing what those boxes look like in the simulation when you try 1, 2, 3, and 4. Okay, so again, I want you guys just to predict how does the volume of the box change as we increase the length of the square cutouts. So again, mess with this first. Try 1, 2, 3, and 4. Look at your boxes. Tell me, if you were to predict how the volume might change for each scenario, what would it be? So again, first you're messing with the simulation. You're trying 1, 2, 3, and 4. And then you're looking at these boxes and you're making predictions. I'm gonna give you guys a minute and a half. Alright guys, so just be very careful. I'm not asking you for the sizes of the box. I'm not saying if the box is smaller, taller, or wider. I'm asking you for the volume. Meaning if you were to go ahead and have something, and you need to go ahead and have all these boxes, which box can you fit more in? Which box can you fit less in? That's what volume is. Okay? So again, if you could fit in more things into that box, then you have more volume. If you could fit less things into that box, then you have less volume. That's what volume is. It's not talking about the actual, like, how big that actual box is. Okay, Dustin? Go. Chris, we have a response? Again, if you need to run them again, like run the simulation several times so you guys can see exactly what's going on, then that's fine. But I need you guys to tell me what's going on with the volume. What do you guys, and again, it's a prediction, right? You are not sure yet. So again, look at the images, look at the boxes. If I were to tell you which one can you fit more into, and you're thinking maybe this one, then that one probably has a higher volume, right? If you can fit it less into a certain box, then it has a very small volume. I want you guys to go ahead and think about that, okay? And then use that to tell me how do you predict the volume is changing as the side length increases. saying, well, it looks like my actual length and my width are getting a lot smaller as well. Alright? Good. And then, so we're saying we started very big and then I think we're gonna get small, right? Now, just by looking at this, remember, these boxes are where you're cutting out. And we talked about this in Unit 1. What happens if you keep cutting a paper? I want you guys to go ahead and think about that. What happens if you keep cutting a paper? Remember this. You just took an exam that asked you something similar. What happens if you keep cutting this paper and you keep making the side length bigger and bigger and bigger? I want you guys to go ahead and write in your whiteboard right now. What is it that you think? So again, what happens if you keep cutting the paper more and more and more, and eventually like bigger chunks and bigger chunks like what you have currently? What is going to happen to the paper eventually? Make sure you're writing your responses in the actual whiteboard right now. So everyone should be writing it on the whiteboard. No one should be on the computer. So again, you have a paper, you're cutting it. Every time you're cutting it, you are seeing what's happening. You saw it on the simulation. I want you guys to go ahead and tell me eventually what do you guys think is going to happen. Take another 20 seconds to write whatever you guys have. No problem. And then as soon as you're done writing your response, look at the corner of your desk, look for the number, check if you are odd or even. Again, check if you are odd or even. Again, check if you are odd or even. Alright, odds. Can you show me who's an odd with your hand? Who's an odd? Who's odd? Jean Pablo or who is it? Peter? We're up here. You are odd? You? You're odd? Alright, so everyone show me again. Raise your hand if you are odd. Odd. Alright, go ahead and take 10 seconds. Go ahead and tell your partner what you wrote. Nicholas, from where? Remember you worked, right? Alright, Evans, go ahead and tell them what you wrote. Alright, Jason, can you share what you or your partner wrote? So great response. He's saying, I predict that maybe after 5 cutouts, I won't have anything. Maybe it'll be to sort of that to the point where it doesn't create a box anymore. Nicholas, do you agree, or is there something else you might want to add? Same thing. What we're talking about. you guys remember the folding paper situation we did? Eventually, remember, rule is that you cannot fold the paper after a certain amount of time. Same thing with this one, right? If you're cutting, you guys see what's left here? It's a very, very small piece of paper, correct? So eventually we know that there's gonna be anything. That if you cut too much, now you can't even fold it into a box. And like he said, well, maybe it happens after 4. Maybe it could be 5 cutouts, right? Maybe it could be 5 inches, and maybe then we might not have anything left. So I want you guys to go ahead and think about that, right? Now that you guys know that, well, let's give it a try. Now that we predicted what that volume is going to look like and maybe what's going to happen eventually to the box, I want you guys to go ahead and actually find the exact volume at different side lengths, okay? So what we're gonna do first is we're gonna do the first one. This is where you need your paper, this is where you need your scissors. I want you guys to grab your paper. And I want you guys to go ahead and choose the length side. I want you guys to go ahead and look at your little one single square cutout. Okay? What you are going to do is you are not going to cut out the entire square. Okay? What you're going to do is only cut one side of it. Again, one side of it. So if your little square measures this much, right? Right now, because it's all 1 inch, you are going to cut only one little side. So from here to here. That's what I'm going to choose. From here to here. And that's all I'm going to cut. To the point where it's just able to bend. But not entirely be cut off. Okay? And I'm going to do that for every single side. Only from here to here. So where it's able to bend. And it's going to show that you now have a square that was cut off. But your paper's still hanging. Does that make sense? Again, only one side so that you can fold it and see that it looks like a square if you fold it over. You're going to do that for every single corner. Good. I see some of you guys are saying like, okay, now it looks like I can actually fold it like a box, right? Now it looks like the first simulation. Again, now it looks like the first simulation that I have right here. Now it's starting to look like this. Great. Cool. So let's talk about this now. Remember, each one of your little corners is labeled what? 1 inch, which is the side length, right? What's the variable that they use for side length? X. Right here, right? So side length is X. In this case, your side length is 1 for your example. Correct? Alright, I want you guys to go ahead and grab your paper again and look at the actual length side. Look at the length side. Any side of the length. So grab your little paper, unfold it if you have to unfold it, and just look at the length side. So in this case, I'm just going to go ahead and look at this length side, right here. Okay? If you wanted to fold it in, and obviously I cut out one piece, how much did I actually cut off? How much is each little box? 1. So I'm, again, cutting 1. And if I want to fold the other side, I also have to cut in another one, and I remove the 1, now I have what? 10. And if I remove 1 more, now I have 9. So my new side length for this box is actually 11 minus, how many did we remove? 2. Good. Alright, let's go ahead and try that with the width. With the width. What is the original measurement of my width? 8.5. And then if I remove 1, how much do I have now? 7.5. And if I remove 1 more? 6.5. Because I took 8.5 minus 2. Good. Alright, go ahead and fold the box now. Fold the box. Fold the box. Fold it into a box really quick. Fold it into a box really quick. Fold it into a box really quick. Alright. If I ask you guys to find the height, what is the height? 1 inch. And you guys clearly see that because if you fold your box in, what do you guys see inside? 1 inch, aka X, right? So in this case, if my side length is 1, that means my height is also 1. Good. And if I want to find the volume of a 3D shape, what do I need to multiply? What's the formula for a 3D shape? Length times width times height equals volume. Good. So that's what you will have to multiply, right? So you will multiply 9 times 6.5 times 1. That will give you the volume of that little box that you have right there. Alright, you guys, we're going to go ahead and continue this lesson next